So now we are into capacitively coupled single tune amplifier. So here, for example, I'm considering two stages. So this is stage 1 and this is stage 2. I'm considering two stages of single tune amplifier, stage 1 and stage 2, for our mathematical analysis. So stage 1, you see, it is a conventional common emitter amplifier. R1 and R2 are going to help in providing voltage divider bias. RECE, you know, it is going to act like a bypass capacitor and emitter resistance. This is going to be my AC source, VSRS. So from FG, I'm going to provide the input to my base. Collector side, you see, I'm going to have an LC tuned circuit. And ideally, you will have only L, but practically, I told you all inductors will have a resistive component inside. So you will represent L with R. So L and R will be in series, and this capacitance, I'm representing it as C dash. The output of the first stage is given to a coupling capacitor and given to the base of the second stage. So since this coupling capacitor is used to connect one stage and second stage, this tuned amplifier is called as capacitively coupled single tuned amplifier. I hope the reason for naming the amplifier is very clear now. It is just like a conventional common emitter amplifier. We use this coupling capacitors as input and output, right? Same way here. For connecting different stages of your tuned amplifier, I'm going to use a coupling capacitance CC. And hence the name capacitively coupled single tuned amplifier. Okay, that is what is explained here. So the tune, I say, consider a C. The circuit is very, very clear. So this is the circuit diagram for capacitively coupled single tune amplifier. And for analyzing this, you know, whenever I'm going to use inductor and capacitor, naturally the amplifier is going to work at a high frequency. So whenever you use L and C, we have also seen oscillators, right? So whenever your L and C come into your oscillator diagram, it means that your oscillator is designed to work at high frequency. So since here also in tuned amplifiers, I'm going to have an LC parallel circuit as a load, I cannot use H parameter model. I'll be using hybrid pi model for analyzing my hybrid pi model for analyzing my transistor. Okay, so hybrid pi model for analyzing my transistor. So I'm going to replace the transistor by hybrid pi model. I hope you remember what is the hybrid pi model. So VSRS will come as it is. You will have RB B dash. B is your base, B dash is your virtual base. And between B dash and emitter, you will have RB dash E and CB dash E. And the voltage is VB dash E. Okay. Between base and collector, you will have RB dash C and CB dash C. Between collector and emitter, you will have GM dash E, GCE, and followed by your load C dash L series with R. I am connecting the output of the first stage to the base of the second stage. So definitely the input impedance will be coming in the load. So definitely the input impedance you have to consider along with the load. So in the load side, you will see C dash parallel to L R in series parallel to Ri. And across Ri, I'm going to measure my V naught. So if you are going to use only single stage, this Ri will be not coming in your diagram. Since I'm considering a two-stage single tuned amplifier connected in cascade, apart from your usual load C dash LR in series, you will also have Ri. Ri is going to be the input impedance of the second stage of your amplifier. Any doubts in the hybrid pi model diagram for a single tune amplifier? Anybody is having queries regarding this diagram, how it has come? I've explained you stage by stage how the components are drawn. So you see, whatever we have seen are all already present for hybrid pi model. Okay, so if you see till this portion, it is by default coming for a hybrid pi model. For other components, whatever you are adding externally, we are attaching the VSRS I am attaching and the load I am attaching. in the load, one small change I also have a parallel combination of Ri, which is the input resistance or input impedance of the second stage of the amplifier. Any doubts in this? Are you clear? Yes. Okay. So same way, that is what is explained here. So it is the hybrid pi model equivalent circuit for a transistor at high frequency, and Ra is the input resistance of the next